In this video, we're going to do some algebra review, and we'll talk about even and odd functions. So I want to talk about each type of thing, an odd function and an even function. We'll review its definition. We'll draw a sample graph of an even function and an odd function, and talk about what type of symmetry that graph possesses. So I'm going to make a table here. Okay, and for type, we will talk about an even function. Let's do an even function first, and then we'll do odd function afterwards. So the definition of an even function is that f of negative x needs to be the same as f of x for all x in the domain. Okay, so let me put a column here. And the graph of an even function, if I draw some axes, it needs to have the property that, so whatever it looks like on one side of the y-axis, so if I look at some x value like this, and I think about what its output is, so this is the point x comma f of x, and I think about what its output is, what that y value is, the y value at x needs to be the same as the y value at negative x. That's what this definition is saying. So graphically what happens is that's going to make the graph sort of be a mirror image of itself across the y-axis. Not a perfect picture, something like this. Alrighty, so the symmetry that this graph has is it's symmetric about the y-axis. It looks like a mirror image of itself across the y-axis. Alright, now let's talk about an odd function. So an odd function. So this is a really similar definition. It says f of negative x is equal to the negative of the original function, negative f of x. So this needs to be the case for all values of x in the domain. So with the graph of an odd function, it turns out that they always have to go through the origin. We could actually show that if we wanted to using this definition, but I'm just going to assume that they always go through the origin. So I'm going to draw one piece over here on this side, and I'm going to label one x value like this. So what this definition is saying is if we look at negative x, that y value should be the opposite of the y value at x, because this negative sign in front. Okay, so that is going to be somewhere down there, and if I draw that happening everywhere, it sort of does this. Sort of does this. Ooh, no, sorry, this shouldn't go this way. It should be like something like this. So the symmetry is now about the origin. All right. So I can think of this as a mirror image, like if I look at this point where x is, if I draw the mirror image of that point across the origin, we'd end up here at this point where negative x is. And that's going to be the case for all of these points. So the mirror image of this point would be somewhere here across the origin. The mirror image of this point would be somewhere here across the origin. Alrighty, so now that we have those definitions and we know graphically what even and odd functions look like, let's do some examples. Okay, so let's test whether the following functions are even, odd, or neither. So part A has the function x squared over 1 minus 5x to the fourth. So the way you test it is you take f and you replace the x with a negative x. So I have to do that for every occurrence of x. I'll get negative x being squared on the top, and then 1 minus 5 times the quantity negative x being raised to the fourth power. Okay, so negative x being squared is just x squared, because when you square that negative, it becomes positive. Similarly, on the denominator, you'll get 1 minus 5, and then negative x to the fourth will just be x to the fourth, because that negative, when you raise it to the even power, will go away. Okay, so notice this is just my original function. It's just f of x. And according to the definition, that makes this function even. It makes that an even function. Let's test this function g of x. Okay, so I'll do the same thing. I'll plug in negative x. In doing that, I'll get negative x times e to the negative x. And so with this, let's compare this to g of x. Well, it's definitely not the same as g of x, so it's not equal to g of x. And now let's compare it to negative g of x. Well, negative g of x would just stick one negative sign in front of it, but it wouldn't change that exponent, that x, to a negative x. So this is also not going to be equal to negative g of x, which means this is an example of a function that's neither. It's neither odd nor even. Okay, and finally let's look at part C. Okay, so we have h of x. Let's plug in negative x here. So we'll get 3 times negative x plus sine of negative x. So 3 times negative x, that is negative 3x. And if I remember stuff from pre-calc about my trig functions, sine is an odd function. If I think about it graphically, the graph of sine is symmetric about the origin. So it's an odd function. Okay, and that means sine of negative x is, I can move that negative in front because it's an odd function. It's negative sine of x. Okay, and with this, I can factor a negative out and get negative times 3x plus sine x. So this is just a negative in front of the original function, in front of h of x. And that's the definition of an odd function. So this function is odd. So in terms of our goals for this section, we finished the first one. We've learned how we test a function for its symmetry, testing to see whether it's odd or even.